Hi everybody, thanks for joining us today for our webinar with Mr. Lorenzo Sacchetti presenting IXPER 75C calcium peroxide and oxygel, two alternatives for aerobic bioremediation of petroleum hydrocarbons. I'm Liz Mueller with Carus Corporation and I will be our moderator for today's webinar. Just a few things before we get started with Lorenzo, a few housekeeping items. Attendees are in listen-only mode. This will help us cut down on the background noise. If you do have any questions during the webinar, as you think of them, go ahead and enter them into the question pane. We should have time at the end for a question and answer session. If at the end, for some reason, we don't get to a specific question, or if we need to follow up with you directly after, we are able to see the email address associated with the question asked, so we'll follow up with you directly. Throughout the webinar, we're going to try out something new today. We're going to have some polls. So we'll have 3 pauses during the presentation today where we'll poll the audience and ask a couple broad questions. PDF of today's presentation. If you're interested in getting a copy of the PDF after the webinar, please go ahead and email me. My email address is here, and I will get you a copy of that PDF. Recording, we are recording the webinar, and it will be available. Typically, we have it available within 48 hours after the webinar. We post it both on our website, which links to our Carus YouTube page, and I will also email the link to all the registrants within 48 hours after. Here's just a quick look. We have one more scheduled webinar for this year for remediation, and it will be Mr. Lorenzo Sacchetti on November 9th. We are hosting it at 2 different times, 7 a.m. and 10 a.m. Central Standard Time. And the topic is OBC and SBC, IFCO and bioremediation in one product. Also, if you are interested in viewing any of our previously recorded webinars, they're available on our website and also our YouTube page. You can access both the registration for the upcoming webinar as well as the recordings at caruscorporation.com. And then you'll see here, if you go to remediation and webinars, you will see all of the links that will either register you or take you to the recordings. And how to find us. So here's our website, our general sales and marketing email address, as well as my email address. And follow us on our social media platforms. So we're active on our LinkedIn page, YouTube, Facebook, and Twitter, where we will commonly post any upcoming presentations that we are presenting at trade shows, seminars, trainings, any webinars that we're hosting, as well as product information. And so here we're going to launch our first poll. So where are you located? And it should pop up here on your screen. And I'll just give it a few more seconds if you haven't put in your answer yet. Great, so it looks like the majority of our audience is North America, and then we have some also in South America and Europe. Well, welcome everyone. And with that, I would like to introduce our speaker. Mr. Lorenzo Sacchetti is the Director of Remediation for Europe, Middle East, Asia, Australia, Africa, and joined Carus Corporation in 2008. Born and raised in Italy, Lorenzo currently resides in Milan. Lorenzo first began working in remediation for a major Italian oil refinery in 1993. During this time, he also taught high school financial mathematics. Lorenzo went on to work for various remediation companies holding positions such as field engineer, project manager, technical lead, and principal consultant before joining Carus in 2008. Go ahead, Lorenzo.
Okay, good morning, everybody. So today we'll talk about a couple of technologies that we propose to our clients for aerobic bioremediation, mainly of petroleum hydrocarbons. So let's go to the agenda today. So we'll talk about a few fundamentals about aerobic bioremediation and then in details about the 2 technologies. Carus Corporation. So Carus is active since more than 100 years with main offices and headquarters in Peru, Illinois, And then we have global operation with offices, European office in Spain, and distribution across the world. So let's say that we sell directly to most of our remediation clients across the world. I would say that mainly our operations are Europe and United States, with other activities in Middle East and Africa, and a few ones in Australia. Simplify science. So this is a Carus claim. So everyone knows that remediation is complex, and in situ remediation, again, is even more complex. And Carus is developing technologies that help to make things simpler. So our technology mainly are focused on reliable chemicals that can be used in a very simple and efficient way to achieve good results. This is a panel of our product range, of our product offerings, cover almost any need of industry. So we can have permanganate-based ISCO reagents. We have sustained release form. We have also activated persulfate, which is OBC. And then we have aerobic and anaerobic products. We have also ABC Plus, which is a chemical reduction, anaerobic bio or ERD enhanced reductive dechlorination. So almost any need is covered. If you go to our documentation, you can find also a selection chart in which we show main chemicals and main challenges you face too, and our treatment. So we have chemical and treatment, including chemical oxidation and reduction, biological treatment, and then you can cross the contaminants and the technology to find out whether our technologies are recommended or not first choice or not applicable to your single case. Okay, this is a well-known image. I think it comes from Todd and Wiedermeyer. It's an adaptation in which we show the difference between aerobic and anaerobic bioremediation. So we will not talk about anaerobic, which is mainly dedicated to chlorinated solvents, and it can be called also the halo respiration or biological reductive dechlorination. But today we will talk about aerobic contamination. In its simplest way, it is bacteria acts as human beings. So as we human beings eat carbohydrates and breathe oxygen to have energy for life, and we produce some waste products, carbon dioxide and water, bacteria does the same. So they take instead of carbohydrates, they take hydrocarbons, which are our contaminants, and they breathe oxygen. In the subsoil, bacteria most of time are in water, so they take dissolved oxygen, and so with the dissolved oxygen they can eat or degrade the contaminants and take energy for their life, for their reproduction, and as a waste product they have CO2 and water. So the target of use of IXPER and Oxygel is mainly to provide the electron acceptors of the oxygen so that bacteria can quickly eat the contaminants. And this is an example of what happens when we have an organic source of organic contaminants. So we have a source area, and then as we go far from the area, we have oxic conditions. So where dissolved oxygen is present, and in the oxic area we have oxygen, and with the addition of IXPER or Oxygel, we mainly stay in the oxide area so that bacteria can breathe the oxygen that we provide to consume hydrocarbons. When bacteria doesn't have any more oxygen, the environment goes nitrate and manganese reducing, iron reducing, sulfate reducing, but these are different conditions that can be differently obtained. But for the target of using IXPER and Oxygel, we stay in this kind of biology. In this bioremediation stage of aerobic bioremediation, we can see that the technology had an evolution. So that at the beginning we had air sparging, so we started with a mechanical system. So we had some equipment injecting air blowing air into the aquifer and then having a physical mass transfer of oxygen from the air bubble to the aquifer, and this was and it is not specifically efficient, and it is limited by the low solubility of oxygen, which at saturation can be 10 to 12 to 14 milligram per liter, depending on site condition and temperature. But after that, new technology appeared. So the first one was powder releasing oxygen, and this is IXPER. And after that, after 2018, we had also some nanogel releasing oxygen, which is Oxygel. So, but in both technologies, the main target is provide oxygen to the aquifer. There is another step, which is the biostimulation of sulfate reducing bacteria, and this is something that we will describe during our next seminar of November 9th. So for today, we will talk about powder releasing oxygen and nanogel releasing oxygen, so IXPER and Oxygel. So IXPER calcium peroxide. So IXPER and the form that we usually sell, which is IXPER 75C, which means 75% calcium peroxide, is a solid powder manufactured by Solvay, both in Europe, in Germany, and the United States, with an available dissolved oxygen content ranging from 15 to 17%. I would say that lastly we are around 17%. Oxygen solubility can go up to 60 and 100 milligram per liter oversaturated. Of course, this is not a stable equilibrium, because this is given by the fact that you have a chemical that releases oxygen over the saturation level, which is in the range of 10-12 milligram per liter. You don't need equipment, you don't need the structures for the implementation of this technology, so you don't need blower, you don't need fans, you don't need any mechanic tool. You usually do by direct push. It requires some injection volume because it's a solid powder, not totally soluble, so you need to prepare a suspension. Typically it's a 20% suspension, but you can inject by direct push, because if you try to inject in wells, you can have some wells clogging effect. You have very low site impact, because after you do the injection, that usually requires a few days, you don't have any other action on the site, and injections can be repeated in a period with ranges in 6 to 9 months. Typically, IXPER continue to release oxygen very strongly in the first 3 to 4 months, and very slowly, but depending on site characteristic, you can go also to 9 months of treatment effect. The beneficial, of course, is the capability to deliver oxygen up to very high concentration, and that the site impact is very small. Mainly you have two kinds of IXPER. It's one, the 75C is 75% calcium peroxide powder, which is very similar to talc powder, very light, designed for injection, and in the FCC format, it is also compliant with the Food Chemical Codex. This doesn't mean that IXPER is a food grade, but it is approved for use in the food industry. So it's a chemical that you can use in the food chain. The other form is IXPER 70C, where you have about 70% calcium peroxide, and in this case you have some granules, alpha millimeter, 2 millimeters, let's say, size, and it's been designed for excavation. Mainly this product has been designed to be dispersed at the bottom of excavation before the excavation is filled in. You have less dust, you cannot inject, you have less available oxygen, and the cost is much higher, because IXPER 75C is produced from IXPER 75. So IXPER 75 is rehandled, is granulated with a granulation product, and then it is sold. So it's much more expensive. Here we will see a few graphs that explain how IXPER can deliver oxygen. You see in this graph that along the time you have still some calcium peroxide remaining. You see that in 24 weeks you have almost consumed half of your oxygen, and the more duration is for the granules, so the line in green that shows that after 1 year you still have some remaining, some 10–15% calcium peroxide remaining, while for the 75Cs, which is the purple one, you don't have any realistic number after 36 weeks. This is, of course, is in the lab, is not in the soil, so it's something ideal. This is another graph that shows what happens with pH in general, as any other peroxide. IXPER 75 has a very high pH, so it stays around the 12 in the injection area, and then outside of injection area pH remain the same. This is a double effect. The first one is that you have less H2O2 and you have more available dissolved oxygen, while the high pH enhances hydrocarbons dissolution. So this helps mobilization and helps hydrocarbons being transferred into groundwater. Just a couple of examples about the calculation of the dose of IXPER calcium peroxide. We have mainly two criteria. The first one is the mass balance, and the other one is the distribution. But almost both must be satisfied. The mass balance criteria says that you will need, as a general rule, for biodegradation of hydrocarbon, you will need 3 kilograms of oxygen to biodegrade 1 kilogram of total petroleum hydrocarbons. So IXPER contains 17% of oxygen, so you can calculate the total mass of IXPER. And the other criteria is distribution. So we recommend to inject at least 10% per volume with a concentration of 10 to 20% of IXPER. And this condition must be verified also after the mass balance. Otherwise, you can have a poor distribution. Here a small example. Imagine to have a site impacted by hydrocarbon, and this total mass has been estimated in 25 kilograms. Let's imagine that this site has an area of 10 meters per 5 meters with a thickness of 2 meters. This means 100 cubic meters. And in this case, we can imagine a pore volume of 25 cubic meters. So according to the mass balance criteria, we will need 3 times the mass of TPH of oxygen. So in this case, we will need 75 kilograms of oxygen for biodegradation. That at 17%, which is the amount of oxygen available in IXPER, you can calculate that the need is 441 kilograms. Let's check now if distribution is okay. So 10% of the pore volume means 2.5 cubic meter of injection volume, and the calculated concentration is 17.6%. So the 441 kilogram over 2.5 cubic meters means that average concentration is approximately, without considering the density, is about 17.6%, which stays in the range 10 to 20%. So this means that in this case, the mass balance criteria gives us also a good distribution criteria. Another example is almost the same site, 10 meters per 5 per 2 thick, but in this site we don't know which is the distribution mass, because maybe we don't have soil data, we have a very limited groundwater data, so a mass balance is not possible. In this case, we can rely on the distribution criteria. So again, 10% of pore volume means 2.5 cubic meters, concentration 20%. This means that in this case, only with the distribution criteria, we can calculate a mass of 500 kilograms of IXPER. As you will see, these numbers came with a very small TPH mass. We are talking about few kilograms of hydrocarbons. This is because the biostimulation treatment of hydrocarbon by means of calcium peroxide or by means of any chemical that releases oxygen has an intrinsic limitation on the amount of oxygen that you can distribute in the soil with the chemical. If we go back to site 1, imagine to have a site impacted not by 25 kilograms of TPH, but by 250, which means 10 times more. This means 4.5 tons of IXPER, which is a very huge amount of chemical to be injected in such a small volume of aquifer, of pore volume. So one thing that you have to say is that in general, this technology is limited at sites with residual contamination or with a minor contamination. So you cannot treat with this technology a site with 1 foot of free phase. An example of a gas station located in Southern Europe. The treatment goals in this case were MTB, NTB treatment, and the target was to reduce below 40 micrograms per liter. It has been injected 200 kilogram IXPER in 2 wells, so 100 and 100 at a 20% suspension. After the injection of the IXPER slurry, water was injected to push the slurry into the aquifer and to clean the well to avoid any well clogging. And in this case, we had ETBA reduction below target, but we observed TPH rebound due to underdosage or presence of a secondary source. You can see the numbers. 2 monitoring well, point of conformity. We see, for instance, well 1, we started with ETB, ethyl terbutylate, which is 151, and then we quickly went below detection limit 44.26, and the target was 40.40. Good results for MTB, while TPH had a rebound at higher values. Well 2 had the same behavior. You see TPH increasing and then going down, and the TBA quickly falling below detection limit, and the same for MTB. In this case, our understanding is that the dosage was enough for treatment of MTB, ATB, but was not enough for hydrocarbon. This is probably due to an upgradient source or to a presence of a secondary source in which injections just gave a mobilization of hydrocarbons. So in this case, the treatment was successful for the MTB, but showed that TPH still needed some additional treatment. And this is poll 2.
Great. So we're going to take a quick pause here, everybody, and we're going to ask the second poll question. So what is your profession? All right, and it is open, so you should be able to input your answers there. Awesome, we'll give it a couple more seconds. And it looks like primarily our biggest audience right now is engineers and geologists, followed by consultants. So great to know. Welcome, everyone.
Okay. So now let's talk about Oxygel. So what is Oxygel? Mainly Oxygel, as you see in the picture, is a gel-based oxygen release chemical. So instead of being a powder that must be dissolved or suspended in water, this is a gel. It's manufactured by our European partner, Biorem Engineering, and in this case, available dissolved oxygen content is 15% against 17% of IXPER. Same condition, the same discussion about the solubility, the same, you will not need any equipment, any permanent equipment. I mean, the main difference with IXPER is that you can inject as it is or with a minor water dilution. So you can inject very easily in there inside with low permeable soil, where it is impossible to inject large volume of injection fluid, and this is the main advantage of Oxygel. Benefits is that it's a stable pump of inorganic gel, slowly releases oxygen in 3 to 9 months. As a matter of fact, there's a lower duration with respect of IXPER. It does not contain oxygen scavenger. It can be added with bacteria nutrients. In this case, the pH is slightly acidic, so you mainly don't see any effect on pH in the soil and in the aquifer. And you don't have any issue on well clogging. You can just put this gel into the well in the saturated section where water is present, and the gel slowly releases oxygen and self-decomposes, so that in few months you don't find almost anything. You don't find any trace of your gel. One advantage of Oxygel is that you can also add a PairMoxa, which is a metal-based catalyst, and in this case you mix the catalyst, you mix the oxygen and inject into the soil. The addition of PairMoxa makes happen a very mild phantom-like treatment. And this treatment is very mild mainly because the hydrogen peroxide is released over the time. So it's a treatment that doesn't leave heating or of gas presence. We had a few experiences of that, and it seems having a quite good effect. Again, how can we calculate the dose for Oxygel? It's the same discussion of IXPER. We have a mass balance, so again 3 kg of oxygen per kilogram of TPH, and then Oxygel has 15%. And the minimum dose criteria this time, it's not based on pore volume, but only in a dose per cubic meter of aquifer. And after you calculate the dose, you can inject as it is, or only have a small injection, a small dilution of 1 part of water, 2 parts of oxygen. This is again the example before. 25 kilograms, 3 times it makes 75 kilograms of oxygen at 15%, 500 kilograms. If we check the minimum dose, so 100 cubic meter per 5 kilogram cubic meters, we have again 500 kilograms. So in this case, mass balance brings to a dose which is right also for the minimum dose. Again, you see that we are talking about few kilograms of TPH. We have an example when we don't know the mass balance, and again, in this case, we can use only the minimum dose criteria and go to calculate a dose of oxygen. This number, 5 kilograms per cubic meter, is a number which is good for medium-low concentration. If concentrations are quite high, you can double this number and go to also to 10 kilograms per cubic meter. One thing which is quite important, at least here in Europe, is the presence of trace metals. In particular in Italy, this is becoming a critical point for public authorities, and public authorities requires analysis of the chemical that you inject, and they require that you don't have any heavy metals. So we had to change a bit our production, and we have to select the product that we use, but we had the third-party laboratory analysis, and the results that you can see are quite impressive. This is a test of over 5 samples of oxygen from February 2015 to January 2017 on the dry matter, so let's say on the oxygen as it is. As you can see, content of mercury is negligible. This is milligram per kilogram. Chromium, hexavalent chromium, lead values are really low. This table is available also for IXPER. It is slightly different, but the results are in any way very low. So if you're interested, we can provide you. And over this analysis, we did also a test, which is an Italian test for, let's say, building waste. So Oxygel is dissolved in water in a 1:10 ratio, weight on weight, and after 24 hours, the leachate is analyzed, and this is to understand how much the Oxygel or the IXPER can release heavy metal after the injection. And again, you can see the numbers for mercury, for chromium, for lead are extremely low, and these numbers are microgram per liter. So the quality of this product is extremely controlled and doesn't impact the quality of the aquifer. We have a case study, again, a gas station in southern Italy. It was a pilot trial to verify the applicability of the technology, and we expected a reduction of at least 50% temporary reduction of concentration, because the test area was in the middle of the site, so we had inflowing concentration. We injected only 25 kilograms in one well with a 1:2 dilution ratio. And after 1 month, we had the increased redox from -147 to 112. This is an average of 3 wells around the injection well. Dissolved oxygen from 1 to 6, and these are the results. You see that benzene drops off about more than 90%. Toluene, ethyl benzene disappeared. Xylene, 1/3. Total petroleum hydrocarbon very low. So after 3 months, we had the stable results, and this is a very, very successful test. And we will go full scale in a few weeks with over 3 tons of product on a site which is a surface about 150 square meters per 3 meters deep. So at the end, IXPER or Oxygel. So mainly the technology is the same. So we use IXPER or Oxygel to provide oxygen to aquifer and to stimulate aerobic bacteria to eat hydrocarbons. So main difference is large injection volume, small injection volume. Oxygen can be used in intact formation because you don't need a big injection, and his formula also helps the infiltration. Oxygel is a gel, IXPER is powder. IXPER can be used mainly by direct push. Oxygel can be used by direct push or wells, and IXPER need powder handling, while Oxygel is a gel. And regarding using wells, again, Oxygel doesn't give any clogging issue, while IXPER can be problematic in wells. Conclusions. Both are proven technologies for aerobic bioremediation, can be applied in time matrices. This is mainly for Oxygel, and has been, when they show very good results for TPH and TB and ATB treatment in medium to low concentration. So this is, again, this is a technology which is not suitable when you have a 3-phase, but if you have medium to low concentration, can give you good results. Okay, so thank you, everybody. And now, Liz, if you can collect any question.
Yes, thank you, Lorenzo. That was great. And we're going to go ahead, and here is our contact us slide. So you have Lorenzo's contact information here, also our U.S. sales managers, which is Troy Lizer and Tim Colgan. And we also have Louis Hernandez in charge of Canada, Mexico, and South America. And then some additional contact information there is also at the bottom. And we're going to go ahead and launch our very last poll. So how did you hear about our webinar today? I'll just give it a few more seconds here. All right, looks like most of you are receiving our email blast from Carus, which is great. If you're not receiving our email blast, you're on this webinar and you're interested in getting on those email blasts, we send out notifications of upcoming webinars as well as newsletters. Go ahead and contact me and I can add you to those emailing blast list. And I'll leave it here on the contact us slide. Just a reminder, a few things, this is being recorded, so we'll have the recording available on our website, our YouTube page, and also I'll send out the link to the recording to all the registrants within 48 hours of today. Also, if you're interested in a PDF of the presentation, contact me. I'll get that over to you. If you have any questions, go ahead and enter those into the questions pane. It looks like we have a couple questions coming in for you, Lorenzo. One is, can you provide a comparative cost for the two products presented today for the two case studies, so the IXPER versus Oxygel?
Oh, I would say that the cost is almost the same, or better. For instance, I have to say that the pricing is different in Europe, for instance, country by country, but as a matter of fact, there is no price difference between the two technologies.
Okay, great. And then another question that came in, you mentioned Oxygel Plus. Can you just quickly recap the benefit of the Oxygel Plus over the Oxygel?
Okay, yes. So while Oxygel is a bioremediation technology in which we deliver oxygen to stimulate bacterial activity to biodegrade hydrocarbons, Oxygel Plus is an in situ chemical oxidation treatment in which we try to have phantom-like chemical oxidation reaction, which means hydroxyl radicals, OH radicals, to destroy the chemicals. So one is Oxygel, straight Oxygel is bioremediation. Oxygel Plus is chemical oxidation. So probably is much stronger, a bit faster than bioremediation.
Okay. And another question that came in is, how is the material delivered to your remediation site?
IXPER is usually delivered in 25 kilogram boxes or in 450 kilogram big bags, because it's very light in terms of volume. So about the 450 kilogram bags is bigger than 1 cubic meter. And while Oxygel is provided or to 100 kilogram drums or to 1.2 tons IBCs. And it's gel form, so you need to pump a bit, and then you can pump with a common double diaphragm pump.
Okay. And then you mentioned, another question is, you mentioned how with IXPER Oxygel, typically they may need to re-inject at some sites in about 6 to 9 months. Are you familiar with what typically would trigger that re-injection? What parameters are they looking at?
Oh yeah, mainly you have to look at the contaminants of concern. So if you are satisfied with the achieved concentrations, and to understand if it is time to re-inject, you mainly monitor dissolved oxygen redox potential. Okay. I would say mainly dissolved oxygen.
Okay, perfect. Okay, that looks like all the questions that have come in now. Again, if you think of anything after the webinar, reach out to us. We will get those answers over to you. And we thank everyone for attending today, and a big thank you to Lorenzo for this great presentation. And everyone have a great day.
Thank you. Bye.